Samsung Galaxy S23 Fake Camera Test. Hello my dear friends, how are you? I hope you are well and in good health. Today I have a new and important video with you, which is testing the Samsung Galaxy S23 Fake Camera. I hope you like it, but before you watch the video, subscribe to the channel to receive everything new and useful. Now let's continue the explanation. At the end of the video, I hope you liked it, and see you in a new video. We put the Samsung Galaxy S23 Fake through rigorous XMark camera tests to measure its performance in photo and video quality and zoom from an end-user perspective. This article explains the device's performance in a variety of tests and several common use cases and aims to highlight the most important results of our testing with a snippet of the data captured. Overview. Main camera specifications. Primary, 50MP sensor, f/1.8 lens, dual pixel f, optical image stabilizer, OIS, ultra-wide camera, 12MP sensor, f/2.2 lens, remote camera, 8MP sensor, f/2.4 lens. Pros: good color rendering, accurate subject exposure and wide dynamic range. Good performance for the ultra-wide camera, effective video stabilization. Cons: autofocus instability and artifacts, for example, moving texture. In low light video, shadows appear on moving objects. Noise in low light, especially in photography mode. The Samsung Galaxy S23 Fake delivered very strong overall performance for a high-end device in the XMark camera test. The overall score is pretty close to the more expensive Galaxy S23 and is noticeably higher than the more budget Galaxy A14 5G. Colors, especially skin tones, were well rendered and images displayed rich detail. The wide dynamic range ensures decent shadow and highlight details in high contrast scenes, and the good performance of the ultra-wide camera makes the Galaxy S23 Fake a good choice for landscape photography. On the downside, some artifacts such as ghosting on moving objects can be noticed, especially when shooting low-light scenes. Results in video mode were also good, especially when recording in daylight conditions. Video stabilization worked effectively and recorded footage at high levels of texture. However, as light levels decreased, artifacts appeared, specifically shaking in some areas of the frame. Test summary about XMark camera tests. XMark camera evaluations are conducted in laboratories and in real-world situations using a variety of subjects. The results are based on objective tests, in which results are calculated directly by measurement software on our laboratory setup, and on perceptual tests, in which a sophisticated set of metrics allows a group of image experts to compare aspects of image quality that require human judgment. The smartphone testing involves a team of engineers and technicians for about a week. Image, zoom and video quality are scored separately and then combined into an overall score for comparison between cameras in different devices. For more information about the XMark camera protocol, click here. More details about the smartphone's camera scores are available here. The following section brings together the main elements of XMark's comprehensive tests and analyzes. Full performance evaluations are available upon request. Please contact us to find out how to receive a full report. The pictures about XMark camera photo tests for recording and analysis. XMark engineers capture and evaluate more than 2,600 test images in controlled laboratory environments and in outdoor, indoor and low-light landscape scenes, using default camera settings. The photo protocol is designed with key use cases in mind and is based on typical photography scenarios, such as portraits, family and landscapes. Evaluation is performed by visually examining images against a reference of natural scenes, and by performing objective measurements on chart images taken in the laboratory under various lighting conditions from 1 to 1000 plus lux and color temperatures from 2300 K to 6500 K. The color exposure and color are key features of technically good photos. For exposure, the main characteristic that is evaluated is the brightness of the main subject through different use cases such as landscapes, portraits or still life. Other factors that are evaluated are contrast and dynamic range, for example the ability to render visible detail in bright and dark areas of the image. Repeatability is also important because it demonstrates the camera's ability to provide the same view when taking multiple photos of the same scene. For color, the image quality attributes analyzed are skin tone rendering, white balance, color shading, and repeatability. For color rendering and skin tone, we penalize unnatural colors but respect the manufacturer's choice of color signature. Autofocus. F-tests focus on focus accuracy, focus repeatability, shooting time delay, and depth of field. Shooting delay is the difference between the time the user presses the capture button and the time the photo is actually captured. This includes focusing speed and the device's ability to capture images at the right time, which is called no shutter lag capability. Even if a shallow depth of field can be pleasing for a portrait of a single subject or a close-up shot, it can also be problematic in some specific circumstances such as group portraits. Both positions are tested. Focus accuracy is also evaluated in all real-life images captured, from infinity to close-up subjects and in low light to outdoor conditions. Texture tests analyze the level of detail and texture of subjects and images captured in the lab as well as in real-life scenarios. For landscape shots, special attention is paid to the level of detail in the bright and dark areas of the image. Objective measurements are performed on chart images captured under different illumination conditions from 1 to 1000 lux and different types of dynamic range conditions. The charts used are the Special Xmark, DMC, chart and the Dead Leaves chart. Noise tests analyze different noise attributes such as density, color, granularity, and structure on real-world images as well as chart images captured in the laboratory. For natural images, special attention is paid to noise on faces and landscapes, but also on dark areas and high dynamic range conditions. Noise on moving objects in natural images is also evaluated. Objective measurements are made on chart images captured at different conditions from 1 to 1000 lux and different types of dynamic range conditions. The chart used is the Dead Leaves chart and the standardized measurement is visual noise derived from ISO 15739. Preview tests analyze image quality in the camera app's preview of an image, paying particular attention to the difference between capture and preview, especially regarding dynamic range and bokeh effect application. Smoothness of exposure, color and focus adjustment are also evaluated when zoomed from the minimum to maximum available zoom factor. Preview frame rate is measured using the global LED timer. Zoom in about Xmark's in-camera zoom test. Xmark engineers capture and evaluate more than 400 test images in controlled laboratory environments and in outdoor, indoor and low-light landscape scenes, using default camera settings and zooming in at various zoom factors from ultra-wide to ultra-long range zooms. Evaluation is performed by visual inspection of images against a reference of natural scenes, and by making objective measurements of map images taken in the laboratory under varying conditions from 20 to 1000 lux and color temperatures from 2300 K to 6500 K. These tests analyze the ultra-wide camera's performance at several focal lengths from 12 mm to 20 mm. All image quality attributes are evaluated, with special attention paid to such artifacts as chromatic aberrations, lens smoothness, and distortions. The images below are an excerpt of the scenes tested. All image quality attributes are evaluated at focal lengths from approximately 40 mm to 300 mm. With particular attention paid to texture and detail. The result is obtained from a number of objective measurements in the laboratory and perceptual analysis of real-life images. Video about Xmark camera video tests. Xmark engineers capture and evaluate more than 2.5 hours of video in controlled laboratory environments and in low-light landscape scenes, both indoors and outdoors, using default camera settings. The evaluation consists of visual inspection of natural videos captured under different conditions and making objective measurements on videos of charges recorded in the laboratory under various conditions from 1 to 1000 plus lux and color temperatures from 2300 K to 6500 K. Colors exposure tests evaluate the brightness of the main subject and dynamic range. That is the ability to render visible detail in both bright and dark areas of the image. Exposure stability and temporal adaptation are also analyzed. Image quality analysis looks at color rendition, skin tone rendition, white balance, color shading, white balance stability and its adaptation when light changes. Texture tests analyze the level of detail and texture of real-world videos as well as graphic videos recorded in the lab. Natural video recordings are evaluated visually. with special attention paid to the level of detail in bright areas as well as in the dark. Objective measurements are made of graphemes taken at various conditions from 1 to 1000 lux. The charts used are Xmark, DMC, chart and dead leaves chart. Noise tests analyze different noise attributes such as density, color, granularity, structure and temporal aspects in real-life video recordings as well as videos of histograms captured in the laboratory. Natural videos are evaluated visually, with special attention paid to noise in dark areas and high dynamic range conditions. Objective measurements are made on video clips of histograms recorded at various conditions from 1 to 1000 lux. The scheme used is the Xmark visual noise chart. At the end of the video, I hope you liked it, and see you in a new video.